Okay folks, let's go through the test answers, see how you got on. I do hope you're not cheating. I hope you've had a go at these questions. I promise that if you watched all the videos and followed along in the module booklet, we have been through all the answers. So if you have been following with the videos and doing the work and stuff and you're still confused, obviously, please drop me an email and if there's anything I can clarify for you, I will attempt to do that. If it's a case of the fact that you haven't been following the videos and doing the work, then there's a kind of obvious solution there. Okay, so question 1, this comes up in physical geography quite a lot. All systems have inputs, outputs, stores and processes, but you can also call the processes flows or transfers. So if you've used those words instead, that's fine. At A level, we can't just say the coast, we need to divide it into sections to be a little bit more specific, and the bit between the high and low tide lines is called the foreshore. So sometimes it's underwater and sometimes it isn't. Question 3. Wind speed, water depth, you also need fetch and the length of time that the wind has been blowing. Deep water, the easy answer is bigger waves. If all other factors were the same, then deep water would give you bigger waves. But of course, in reality, the deep water could be cancelled out by the fact that it wasn't a windy day or something else. But if all factors were equal, deep water gives you bigger waves. The waves that are created by distant storms are called constructive. So just to jog your memory on this, if you're at the beach and it's a really beautiful sunny day and there's hardly any wind and there are still waves, they are created by storms somewhere else. There will always be a storm somewhere on the planet, and those waves will travel until they hit all of the surrounding coastlines. So that's constructive. And then the waves that are created by local storms that tend to destroy things are destructive. Question 5, constructive. Question 6, destructive. The movement of water up the beach is swash. Okay, so backwash is back down, swash is up the beach. Constructive waves, the type of waves that make your beaches bigger, which is why they're called constructive waves, because they are constructing your beach. They are spilling waves, they kind of fall over each other, whereas a destructive wave is much more of a plunging, kind of dangerous, destructive motion. So destructive waves are described as plunging and constructive waves are described as spilling. Okay, now this might be an area that you're not too sure of. I'll give you a page reference actually. Page 6 of the module. If you haven't had a chance to look at that page yet, this is where you would find the answers to that. We looked at that page when we were talking about constructive waves, destructive waves, swash, backwash, that kind of thing. So, question 9 anyway. A is the crest of a wave, and I'll say it now, C is the trough. So the top bit is the crest and the bottom bit is the trough. B is the wave length and D is the wave height. Okay, but as I say, check page 6 if you're a bit unsure. Waves break because the bottom of the wave goes into shallow water and slows down. The top of the wave is going at the original speed and the whole thing tips over. I'm not being too precise with the 2 marks. If you've got that general gist, then that's fine. You can give yourself 2 marks. The analogy I used when I was explaining this is like you tripping over. So your foot kind of gets stuck on something. The top half of your body is going at the original speed, and if you're not careful, you go over on your face. Hopefully not, of course. Question 11, that's wave refraction. So if you knew the name of it, you can get a mark. What's happening, I was just turning the page to get a page reference. Page 7, there are some diagrams. In the turquoise section, that's symbolising going into shallow water. The only reason you would know that is if you watched the video on wave refraction and took lots of labelling notes. So what happens to waves is If part of the wave goes into shallow water, as symbolised by the turquoise, that part of the wave will slow down. The rest of the wave is travelling at the same original speed, and so because of refraction, because of the change of speed, you get a change of direction, and you can see that the wave completely changes direction. So you can get 1 out of 2 for knowing the name of the process. You can get the second mark for understanding it's to do with going into shallow water. Question 12, should we try that again? Question 12 is the tidal range. That's quite an important phrase in this module. Question 13 is false. Spring tides are the highest high and the lowest low. So it's the biggest difference in tidal range. I'll give you another. There's a really nice diagram on page 8 to help you understand that. Spring tides are when the sun and the moon are working together. Whereas if the sun and the moon are at 90 degrees, it's 90 degrees neap. So the answer to question 13 is false. The 4 types of coastal erosion, I did give you an optional 5th, so you will get 4 marks for any 4 of these. Hydraulic action, wave pounding, abrasion, corrosion or solution, and attrition. Page 10 if you need it. 3 factors that affect the rate of erosion on a coastline. Well, hopefully you've been doing me a 15 marker all about this. Page 14 has all the options. It's how big the waves are, or how much energy the sea has got, the geology, whether there's coastal protection, whether there's a beach or not, whether there's been dredging, what the weather is doing, all that kind of stuff. Okay, so any 3, you can give yourself 3 marks. Page 14 has the answers. Which type of erosion is more dependent on rock type? That solution or corrosion, it's the dissolving one. And that has a huge amount more to do with rock type than anything else. Some rocks dissolve really easily, some rocks really don't. Question 17, okay, weathering. Physical, there are 3 types of weathering: chemical, physical, biological. Physical is a breakdown in structure with no chemical change, and chemical weathering is where there's a chemical reaction. So the chemical structure of your rock actually changes. So as long as you've got the general gist, that will do. Question 18, you've got 5 choices here. You could have done freeze thaw, salt crystallization, water layer weathering, exfoliation, or pressure release. I'm going to do them in a nutshell. So freeze thaw, water goes into cracks in the rocks, freezes, expands. You can have a bonus point here if you know that it freezes, it expands by 9% in volume. Freezes, expands, thaws, and you just get a repetition of that and it breaks the rock apart. Salt crystallization, salt water goes onto the rock, the pure water evaporates, leaving salt crystals behind, and as they grow, this sounds bonkers, but trust me, as those crystals grow, they actually are powerful enough to break rocks apart. It makes the rock look a bit like honeycomb. You get these kind of circular indentations. Water layer weathering is easy. Water gets in between the layers in your rock and actually forces them apart. Onion skin weathering or exfoliation is to do with hot and cold, hot and cold, hot and cold. It happens in deserts mostly. So your rock heats up and expands, cools down and contracts, and that process repeating eventually will mean that your rock breaks apart. And pressure release is kind of hard to explain, but if your rock had been covered in millions of tons of other rocks, and then over thousands of years, those rocks that used to be on top of it get weathered and eroded away, what you end up with is that rock kind of expanding, a little bit like when you stand up from your sofa, the sofa cushion kind of recovers and it goes upwards. Well, the thing about solid rock is, as it does that, it cracks, and that's pressure release. Okay, so you just needed one of those, but you've got a few options. Question 18. Weathering weakens rocks and makes them easier to erode. That's question 19. Question 20. It's the internal deformation. So a slump, everything kind of stays intact. It just goes downhill a little bit. Whereas with a landslide, everything's really jumbled up at the bottom. It's a right old mess. Question 21, the direction of longshore drift depends on the wind direction, because swash will always happen in the direction of the wind, whereas backwash is always at 90 degrees. So your longshore drift is completely dependent on the direction the wind is blowing in. Question 22, if traction and solution are two types, what are the other two? You've got saltation and suspension. Answers for that you can find on page 13 if you need a bit more help with that. Question 23, sediment is deposited and water slows down. Yeah, that's absolutely true. A bit like humans, if you lose energy, you kind of need to put down what you're carrying, and that's what water does as well. Question 24, please don't penalise your spelling, but the word is flocculation, such a great word. The spelling of it, if you need it, is on page 13. Flocculation. The key message of the Hall Sands case study is that dredging is bad. Dredging is where you remove sediment from the seabed for various purposes, but because the coast is a system, if you change one part of a system, it will have knock-on effects on the rest of that system. So by removing the seabed in front of Hall Sands, the sea then took the beach away to replace the seabed. The village didn't have a beach to protect it, and the village was destroyed in a storm. So that's the key idea of it. Okay, so I know that will annoy some of you that it doesn't add up to a round number, but the test is out of 42 marks, so you can add up what you got. And as I said at the beginning, if you have been very good and very diligent and you've watched the videos and you've been doing the work and any of those questions were really tricky, then please get in touch. If you didn't do very well in that, but you know why, which is maybe you haven't been doing as much as you should have been, there is a kind of obvious fix there. Okay, now some of you may have noticed that this goes on to landforms. I haven't taught you those yet, so I've kind of just ignored them for now. We will get to that point, ladies and gents, obviously. New coastal stuff is on some other videos, okay? So thanks very much.